Okay, this video is going to hopefully get you prepared for a lecture on slopes and equations of lines. And we're just going to jump into it. So picture a line in your head, and slope is talking about the inclination that the line is at. So it's rise over run, or pitch, like pitch of a roof. So slope is the horizontal run over the vertical rise or fall. And the formula for slope is given by m equal y2 minus y1, x2 minus x1. M is traditionally the variable that we use to represent slope. So first thing we have to be able to do is find slope. Well, I have to give you 2 points. So here's 2 coordinates I'm giving you, and we have to label what x1, y1, x2, y2 means. x1, y1, well, x1 is the first x value, y1 is the first y value. x2 is the second x value, y2 is the second y value. And if I switch these points around, it doesn't make any difference. The formula is always going to work out. So I can consider this the first point, or I can consider that the first point. So once I label these, and it's a good idea to label them. A lot of times in class you'll see when I do this, I'll put the labels right over the points on the board. And then we'll fill in the formula. M equals, I always write out my formula with nothing in it first. Then I'll actually put the values. y2 minus y1 over x2 minus x1. Then I simplify. Again, put in lowest terms. I like moving the negative to the top. And what this means is for every 3 units to the right, that's what the 3 is the run, is positive. So every 3 units to the right, the rise is going to be -1. So instead of rising, it's actually going to fall. So 3 units to the right, down 1. 3 units to the right, down 1. And that is going to be between any 2 points on that line. 3 units right, down 1, 3 units right, down 1, and you'll get the pitch of that line or the slope of that line. Second example, scroll this up a little bit. A little more complicated. I'm throwing more negatives in there. I'm not going to talk my way through all of it. You can go ahead and pause it and see if my work is right. And we'll just go from there. But when the dust settles from this one, 3 over -7, I myself always move the negative up on front here or on top. I like that on top. So it means 7 units right, this one's going to fall 3 units. All right, these can get more complicated. I could use decimals, I could use fractions here, but this is the concept to get you used to using the formula. Now a couple special cases. This one here, example 3, I have the coordinate 511 and 518. And you might want to take out a piece of paper and sketch that really fast. Pause this, sketch it, and connect the dots and think about what kind of line that is. If I follow our procedure, labeling the points, putting it into the formula, and I see I get 7 over 0. Well, I can't divide by 0, so that does not exist. So that means this slope doesn't exist. Well, what kind of line has a slope that does not exist? Well, it's a vertical line. This is telling me I have infinite slope. I have 0 run. So it's straight up and down. It's just going straight up and down. That is a undefined slope, vertical line. And I'm going to emphasize this in lecture more than on the video. Next one, very similar. Plot these and connect them. Label everything up. Put in the formula. Watch your signs. These things can trip you up with the signs. I end up with 0 divided by 12. That's the same thing as 0 times 1/12. Regardless, you get 0. This means I have 0 slope. I don't say no slope. No slope is more correct for this one than here. This has 0 slope, which means there's no 0 rise. This line is just going to go horizontally. Horizontal line. So that brings us to equations of lines. So you might want to pause and go back over the slope one again, rewind it, practice that a couple times. When you get ready to start up with the point or the slopes of lines. I use point slope form for finding the equation of the lines. There's other ways of doing it. If you learned it a different way, I don't care. You can use that way. This is the one way I'm going to show you to do it. So if you can do it correctly another way, that's fine. Point slope, to use this, I need a point, x1, y1, and I need a slope, m. So example 1 on this, I'm giving you a slope, I'm giving you a point, and I'm plugging it into the equation. And when I get that plugged in, I simplify a little bit. The only thing I'm simplifying from this step to the next is minus minus is a plus 2. And then going from here to there, I'm distributing the negative 5 in. That brings me to this step. I have y minus 11 equals this, so I'm going to add 11 to both sides. And the goal here is to get y by itself. Y equals negative 5x plus 1. This is called slope-intercept form. It's called slope-intercept form because I can look at this equation and rapidly see that the slope is negative 5. That's the coefficient in front of the x. That's your slope. So this I could also think of as negative 5 over 1. So for every 1 unit to the right, it's going to fall 5. And the y-intercept, well, the y value of the y-intercept is 1. The coordinate would be 0, 1. And MyMathLab will sometimes ask you when they say y-intercept, they want the coordinate. So you want to bear in mind it's just not 1, it's the coordinate 0, 1. Get to example 2 here. Example 2, slope is equal to 1/3. Email popping up. Slope is equal to 1/3. The point is 6, negative 2. Find the equation of line in slope-intercept form. So I'm going to use the equation I posted above. I should have put it here. So let's scroll right back up. There's my equation. And I'm going to fill this in. Y minus y1 equals m times x minus x1. I simplify my minus minus to a plus. I distribute my 1/3 in. Next step, I'm going to simplify minus 1/3 times 6. That gives me minus 2. I'm now going to start solving this equation for y. So I'm going to subtract 2 from both sides. And I'm going to end up with y equals 1/3 x minus 4. The slope is, again, the number in front of the x is 1/3. We already knew that. The y-intercept is 0, negative 4. Okay? All right, example 3. Find the equation of a line that goes through the points 4, negative 2, and 7, 15. Well, I didn't give you a slope, but I gave you the 2 points, so you can utilize this formula to find your slope. And when you do, watching your signs, you'll get the slope of 17/3. So this is nasty. This is a nasty one. I'm just saying it. This is like a worst case scenario. So your slope is 17/3. Now you're going to pick one of these 2 points. It doesn't matter which one you use. It's always better to pick a simpler point. To me, this one's simpler, but that's preference. And I'm going to go back to using this formula. I'm going to plug in my y1, my x1, and my slope. And again, stepping my way through this, simplify my signs, distribute. I have to take 17 times 4 to get to 68/3. Remember, when you multiply a fraction times that number, you're only multiplying the numerators. I'm going to subtract 2 over. To add fractions, subtract fractions, I have to get a common denominator. So I'm going to take this one times 3 top and bottom. Add it together, and I get y equals 17/3 x minus 74/3. So the slope is 17/3, and this y-intercept is 0, negative 74/3. So again, this is tough. This is tough. There's a lot of little things to keep track of. You got your fractions going on, which we all love, and our minus signs. My suggestion is go back through the first ones, step your way through it, use this as a reference, and then try this one yourself off to the side and see how that goes for you. Okay? Thank you.